So this is the first section dealing with trigonometric ratios. I've got part one because if you were to go to your textbook, 4.3, which is where this topic is found, extends into something else that we'll do tomorrow. What we're doing is finding trigonometric ratios. This is on page 21 of your unit handout. We're going to be solving problems involving the 6 trigonometric ratios on the coordinate grid. And as far as you're concerned right now, that probably wouldn't make a lot of sense because you are aware that there is a sine ratio of theta, a cosine ratio, and a tangent ratio. Well, I'm telling you there's 3 more ratios. And that's what we're going to learn about today. This is a huge, huge extension of what you already know from Math 20. Okay, so we're going to review some stuff from Math 20 first. For any point that lies on the terminal arm of a rotation angle, for any point, this is not necessarily a unit circle. The length of that arm from the origin to point P could be 1 for what I'm talking about. It could be 10. It could be 8. It could be 3.5. It doesn't matter. For any point, we can determine the values of the rotation angles. We can determine the values of the trigonometric ratios of the rotation angles by using x, y, and r. How many of you remember from last year that cosine of theta is defined as x over r on the coordinate grid? Okay. By the way, if it's the unit circle, what is the value of r? 1. That's why on the unit circle, cosine of theta is x. Sine of theta is y over r, and tangent of theta is y over x. And although that diagram that I have drawn shows theta in quadrant 1, these 3 definitions, it's deeper than saying just a definition, but these 3 statements are true regardless of the rotation angle. It doesn't matter where the rotation angle ends up terminating in terms of an arm. That, of course, leads to all kinds of conclusions that cosine of theta will be positive anytime the point is in quadrant 1 or 4 because x would be positive. Sine of theta would be negative anytime the terminal arm lands in quadrants 3 and 4 because in quadrants 3 and 4, y is negative and sine is y over r. So I hope you recall kind of having to think about that last year when you were doing some trig problems. Well, these are the 3 primary trigonometric ratios. And you may have heard your math teacher or myself call them that. And it isn't because they're trying to confuse you. It's that they know there are other trig ratios that you don't know about yet, and they forget that. So there are primary trigonometric ratios of cosine of theta, sine of theta, and tan of theta. Each of those primary trig ratios has what we call a reciprocal trig ratio. And reciprocal trig ratios are important because they make math at higher levels easier to handle. So if you go on and take calculus next semester, you will be taught that when you're doing certain things like finding derivatives or finding critical values of a second derivative or whatever the case is, and it's trigonometric, it's much easier to work sometimes with reciprocal trig ratios instead of primary trig ratios. It isn't just that we're saying, oh, let's load more on your plate. This course is designed around pre-calculus. It's designed for calculus students, ultimately. We have this reciprocal trig ratio, and I'll tell you what it's called in a second, but this reciprocal trig ratio is the reciprocal of cosine. This is the reciprocal trig ratio for sine, and this is the reciprocal trig ratio for tangent. And these have words or names. This is called the secant of theta. You'll get used to it. You will. This is called the secant of theta. So I'll talk more about this in just a minute or two, but when I say the secant of theta is equal to 1 over the cosine of theta, I'm just saying that the secant of theta is the reciprocal of whatever cosine of theta is. If cosine of theta is root 2 over 2, then secant of theta is 2 over root 2. It's just the reciprocal. It doesn't necessarily mean you have to write 1 over something. But the thing I want to point out to you is that reciprocals are reciprocals of each other. It's the only operation in mathematics where this is true. That if you take a number like 2/3 and you reciprocate it to get 3/2, and then reciprocate the 3/2, you're back at 2/3. If I take a number and divide it by 2 and then continue to divide by 2, I don't get back to the beginning. This is the only operation in math where that happens. And my point is, these two numbers that I've written are reciprocals of each other, which means I could write cos of theta equals 1 over secant of theta. I don't want you to think of this as a formula. I want you to think of it as a statement that cosine and secant are reciprocals of each other. This is called cosecant of theta, and this is called cotangent of theta. These are on your formula sheet. Now we'll get to that in just a second, but just how I was taught, and I mean, I'm sure we had a formula sheet when I was in high school. I just don't remember. I was taught that each of these pairs has a co in it. Cosine and secant, there's a co. Cosecant and sine, there's a co. Cotangent and tangent, there's a co. And this is pretty easy to pair up, right? Cotangent and tangent, they go together. So then if you say, what's the reciprocal of cosine? And you say, is it cosecant? It can't be, because there's only one co in each pair. Anyway, as I said, these are reciprocals of each other. I may have used a different illustration, but if I say cosecant of theta is the reciprocal of sine of theta, I could say sine of theta is the reciprocal of cosecant of theta. Are you with me on the intent of this and what I'm telling you? Okay. So they are on your formula sheet. If you were to go to your formula sheet under trigonometry along with boatloads of other stuff, you have the arc length formula, which we've already learned. And then a little bit further down, I don't know what's under here. Oh, yeah. There's some other stuff there. Okay, we won't worry about that. A little further down are those three reciprocal trig ratios that we need to know to work with trigonometry at this level. What this means is the following. Now, in grade 10, on a formula sheet in grade 10, you were told sine of theta is opposite over hypotenuse, all that stuff. Remember that? And then last year, you were given this as a replacement on the formula sheet. Instead of saying adjacent over hypotenuse, cos of theta is x over r, and you were given this and you were given that, right? Okay, so you're not given that this year. It's not on your formula sheet. You need to know that. But now you also need to know three more facts. That if cosine of theta is x over r, and listen to the words, then secant of theta is r over x. Because cosine and secant of theta are reciprocals of each other. And everything we do today, all of the examples we do today, except for, I think, number 1, are Math 20 examples that now use other trig ratios. So everything I ask you today, other than the unit circle question in number 1, you could have done last year as long as it was limited to cosine, sine, and tangent. Cosecant is the reciprocal of sine, and I always have to work this out. Sine is y over r. Well, that means cosecant is r over y. What is cotangent? Well, tangent is y over x, so cotangent is x over y. And these are facts that you need to know. They're true for any rotation angle, no matter the point on the terminal arm. If the point intersects the unit circle, or if the point doesn't intersect the unit circle, these are true. Just a reminder here, r is the distance from the origin to the point. And you need to know these. Okay? It's not negotiable. You cannot be successful in trigonometry from here moving forward without knowing these facts. They're not provided on your formula sheet. Now, if the point is on the unit circle, and this is where we have to be careful that when you're solving a problem, you have to say, is it on the unit circle or is it not? Because if it's not, you have to do this. If it is, you don't have to do this. Because if it is on the unit circle, this is 1. R is 1. This is 1. So what happens is all of these become that. So instead of saying cos is x over r, we just say it's x. But this is only true if it's on the unit circle. So example number 1. Use your knowledge of the unit circle to determine the exact value of these things. Well, it's the terminal arm of this rotation angle of pi over 3 intersects the unit circle. It's a fact. It intersects a lot of other circles. But why would you try to solve this problem by imagining it intersecting a circle of radius 5? Why would you do that? You could. There's a way to do it. Why wouldn't you just say, let's look at it intersecting the unit circle? Because there will be a point. And we know what the coordinates of that point are. Pi over 3 is here. This is what I talked about earlier today and yesterday, where you build the unit circle in pieces as you need it. So this is a unit circle, which means that this is 1 and this is 1. Is that a point that has the root 2 over 2 combination? No. It must be 1/2 and root 3 over 2. And I really hope that with just a little bit of thought, everybody can see that that the x coordinate, I really hope that with a little bit of thought, start again. I really hope that with a little bit of thought, you can see it's the x coordinate that's 1/2. Right? You're just dropping this down and you're saying, no matter how, you'd have to draw a pretty lousy circle not to see that it's a half. Right? You'd have to, I don't know, drink a bunch of coffee and so your hands shaking and then try to draw a circle. It's going to be obvious, which means you're going to be able to do this. That means that this is root 3 over 2. And that means that this trig ratio is root 3 over 2. Because sine is y over r, and the y coordinate is root 3 over 2, but r is 1 because it's the unit circle. I would say that this, everything in red, from here on in, you shouldn't have to draw it. You should almost be able to visualize that. What is cosecant of negative 5 pi over 4? Well, we need to locate negative 5 pi over 4, so we can talk about x and y. And again, I'm going to use the unit circle because I know the coordinates of the points on the unit circle. I don't know the coordinates of the points on a circle of radius 5. I could figure them out and just multiply all the unit circle points by 5, but why bother? So 5 pi over 4, negative 5 pi over 4, 5 pi over 4 is multiples of pi over 4, which is 45 degrees. There's negative 1, negative 2, negative 3, negative 4, negative 5 pi over 4. And everybody should know the coordinates here are negative root 2 over 2, comma, root 2 over 2. Are you with me on that? Okay. Or negative 1 over root 2, comma, 1 over root 2. You can use either one. Doesn't matter. So what am I asked for? I'm asked for cosecant of theta. And this is what happens in my head. I say cosecant of theta is the reciprocal of sine of theta. That's what's going on in my head. And then I say sine of theta is y over r, which means that cosecant of theta is r over y. What's the reciprocal? But it's the unit circle. So in this case, and I don't like to go equals equals, but I'm just going to this one time. It's the reciprocal of y. Or, if you like, this thing that I'm going to highlight is sine of negative 5 pi over 4. So cosecant is the reciprocal of that thing. But I think it's smarter to reciprocate this one rather than the other one, because I get a simpler answer, don't I? The reciprocal of root 2 over 2 is 2 over root 2. That's pretty messy, whereas the reciprocal of 1 over root 2, which is the same thing, is simply root 2. If you had a cosecant button on your calculator and you don't, and you entered cosecant of that, you would get root 2. I do want to demonstrate this to you. Take your calculator let's put it in radian mode. How is it, if I wanted to, how is it that I could find a decimal approximation of this trig ratio, which I'm going to highlight in blue? How would I enter this trig ratio? Well, I do not have a cosecant button. This does not mean I'm going to take the sine of the reciprocal of this number. That's not what it means. This is the same as 1 over the sine of negative 5 pi over 4. This is the only way I can enter it in my calculator. I have to go 1 divided by sine of, and then enter that angle. 1 divided by sine of negative 5 pi divided by 4 gives me this number, which is the square root of 2. Okay. Tan of negative 11 pi over 6. Negative 11 pi over 6 is here. If you look at my arm, negative means I'm going clockwise. Negative 1, 2, 3, 4, 5, 6. Pi over 6 is 30 degrees, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The coordinates here are root 3 over 2, comma, 1/2. You can see that my arc is not great here because when I look at the y coordinate, it looks like it's less than 1/2, right? But I hope it's clear that the alternative, the x coordinate, is clearly close to 1. So tangent of theta, this is what goes on in my head. Tangent of theta is y over x. So all I have to do is write y divided by x. Just in preparation for particularly the next unit, do not simplify something like this by multiplying by the reciprocal. Simplify it by saying, I'm going to multiply the top and the bottom of this expression by 2 to clear out all of those little denominators. And what happens on the top is these cancel and these cancel on the bottom, so you get 1 over root 3. Okay with that? Or root 3 over 3. If 1 over root 2 is the same as root 2 over 2, 1 over root 3 is the same as root 3 over 3. You can accomplish that. I want to be aware of the time today. You can accomplish that by rationalizing the denominator. I hope everybody remembers this from last year. You multiply the top and the bottom by the radical on the bottom, and you would get root 3 on the top and 3 on the bottom. D, I understand D is not where D should be. It's kind of in your note package off and to the right. I don't know what I was thinking there. Cosecant of 3 pi over 2. Well, P of 3 pi over 2 is 0, comma, negative 1. I'm not going to draw a circle for that. 3 pi over 2 is at the bottom of your unit circle. The x-coordinate there is 0. The y-coordinate is negative 1/2. Cosecant of theta. And I just cannot write down what it is in terms of x, y, and r without every time doing this. Cosecant is the reciprocal of sine. Sine is y over r. That means cosecant is r over y. And because we're employing the unit circle, I can just go 1 over y because r is 1. All I have to do is take the reciprocal of the y coordinate. 1 over negative 1, which is negative 1. Cotan of 240. 240 degrees is right here. So I'm adding less and less to my diagrams. I'm not even drawing an arc this time. The coordinates of that point are negative 1/2, comma, negative root 3 over 2. Cotangent of theta is x over y. Why? Because tangent is y over x, and cotangent is the reciprocal of tangent. So I need to take x, which is negative 1/2, and divide by y, which is negative root 3 over 2, and we happen to get 1 over root 3. The 2's cancel. One final one, secant of negative 45 degrees. Well, I just want to ask this question. How many of you know, with a little bit of thought, it's not a memory thing, I don't think, that at negative 45 degrees, cosine will be 1 over root 2. It's the x-coordinate of that point. Why did I put 1 over root 2 as opposed to root 2 over 2? Because I'm about to take the reciprocal of it, because secant is the reciprocal. Why not go with the thing that becomes easier to look at when you reciprocate it? So I take the reciprocal of 1 over root 2. This is equal to root 2. Are we okay with that? You were going to need to know these trigonometric ratio values. Find them very quickly. All right, let's take a look at example 2. This point lies on the terminal arm of a rotation angle theta. Show that that point is actually a point on the unit circle. What's the only way you can prove that that's a point on the unit circle? Do you know, Jacob?
The numbers squared added together equals the radius squared.
Which is 1, right? So, yeah, the numbers squared added together has to give you 1. Let's do this without a calculator. We need to find out what negative 5 over 13 quantity squared plus 12 over 13 quantity squared is. What I mean is I don't want you to just enter everything into your calculator. If you need your calculator to determine that 13 squared is 169, okay. But I square the negative 5, and I get 25. 13 squared is 169. Plus 12 squared is 144 over 13 squared is 169. We have a common denominator of 169. So you get 25 plus 144 over 169, which is 1. This is a nice little, I don't think it would be the full 2 marks, it would be more, but a nice little kind of written response thing where you have to demonstrate that a point lies on the unit circle and then do something with it. Determine the values of the 6 trigonometric ratios. Well, this is easy. This is not a time-consuming process, this question. Cosine is negative 5 over 13 because that's the x-coordinate and we know it's on the unit circle, so that's the cosine. The sine is 12 over 13. It's the y-coordinate because it's on the unit circle. What is secant? Well, it's the reciprocal of cosine. And I know that when you reciprocate negative 5 over 13, you get 13 over negative 5. But having a negative in the bottom of a numerical fraction is probably not what you would ever see. You would see it just either written on the top or out in front. And once again, I've mentioned this before, I'm sure, with you. I just despise doing this. I don't like that negative out in front because very often students don't see it. That being said, it sometimes is typed in front, so you have to watch out for that. Cosecant would be the reciprocal of sine, which would be 13 over 12. The only real work we have to do here is figure out what y over x is. And, you know, the fact that I drew that middle line, and there's a name for it. We were just talking about this. I was talking about it with another math teacher the other day, and I always forget the name. It's a goofy Latin name. The fact that that middle line is drawn so long is important. It's a fraction over a fraction. If you multiply the top and the bottom of this by 13, to clear those fractions, what you get for tangent of theta is negative 12/5. I mean, you get 12 over 5, and the 5 is negative, so you have to put the negative somewhere. That means this is negative 5 over 12. That's all there is to this, basically. I mean, it's going to get a little more complicated, obviously. But so far, this is a pretty simple example. Any questions with example 2? All right. Look at this point in example 3. Does that point lie on the unit circle? Well, no. Those x and y coordinates are way outside the domain and range of the unit circle. Unit circle goes from -1 to 1 for x. You're not going to have a point with this, which means we cannot say cosine equals x, but we can say it's x over r. And we can say that sine is y over r, and tangent is y over x, and then reciprocate whatever we get for those. So what are we missing that's preventing us? Well, I guess we're not missing anything here. I can write the tangent of theta, can't I? It's y over x. So now things get a little bit sticky. You understand that I wrote negative 8 over 3? I'm not telling you y is negative 8. In fact, if all I told you was this statement, you don't know whether y is negative and x is positive or the other way around, right? Okay. So we could write cotangent. That's a piece of cake. You flip tangent. What are we missing that's preventing us from writing down what cosine or sine are, Noah? R. How are we going to find r? Right, x squared plus y squared equals r squared. That's why yesterday when we did the equation of the unit circle, I then said, well, what if the radius was 3, or whatever it was? So it's x squared plus y squared equals r squared, which means you have negative 3 squared plus 8 squared equals r squared. I think that's going to be 73. So r is root 73, not plus or minus, because r is always a positive quantity. We're kind of done here. Cosine, I'll just write it in a different color because I'm a little crowded here. Cosine will be negative 3 over root 73. It's funny because in Math 20, it's hammered into you that, oh, we can't have radicals in the denominator. Let's multiply top and bottom by root 73. And in Math 30 in calculus, we pretty much don't care. Sometimes we want the radical in the bottom. But if you were to multiply the top and the bottom by root 73, this is what you would get. And it's why I've always said that whole rule of rationalizing the denominator to make things simpler, it just doesn't make sense. That's not simpler. That's more complicated. I suppose you could see this on an exam. I suppose you could. I doubt it, though, particularly with big numbers. Sine, I'm just going to erase this because it's really not important and it's in my way. Sine will be equal to, I guess, 8 over root 73. And then the secant and cosecant, we flip those over. You're still with me here? Okay. So secant will be negative root 73 over 3. Cosecant will be root 73 over 8. And we're done. So example 5, angle B lies in quadrant 3 and cotangent of theta is 2/3. What's the exact value of secant of theta minus cosecant of theta? Well, that means you need to determine these two things. This is going to be r over x, This is going to be r over y. Think about that for a second. That secant is the reciprocal of cosine. Cosine is r over, or is x over r, so you reciprocate it and get r over x. Cosecant is the reciprocal of sine. Sine is y over r, so we reciprocate it and get r over y. The ideas we're using to solve these problems are not complicated. You just have to think carefully. So what do we know here? We also know cotangent of theta is x over y. Can you just ponder that for a second, that cotangent of theta is x over y? Because tangent's y over x and cotangent's a reciprocal. So that means if this is equal to 2/3, x is 2 and y is 3. How many of you are okay with that? Because it's not true. Abby, what's wrong here? They need to both be negative because it's in quadrant 3 where x and y are both negative. You don't see the negatives because when you take a negative divided by a negative, you get a positive and it's hidden from you. So now what you need to do is find r. Negative 2 squared plus negative 3 squared is r squared. I want to say r squared is 13. 9 plus 4. R is root 13. That means the thing we are after will be root 13 over negative 2 minus root 13 over negative 3. And we have a little bit of arithmetic to do here, numerical math. First things first. Since I'm dealing with fractions, I'm going to want to get a common denominator, and using negatives in denominators to find common denominators is just not necessary. It's confusing. So I moved the negative from the bottom, where it's on 2, up to the top, and I've canceled these two negatives. My common denominator is 6. So I need to multiply. Man, if you want to write this, you certainly can. But I don't think you need to. I'm multiplying top and bottom of each of those two fractions by a number that will give it a denominator of 6 in each case. So I get negative 3 root 13 plus 2 root 13, and this is all over 6. I get negative root 13 over 6. Negative 3 plus 2 is negative 1. You know, it could be that, what were we asked for? Secant of theta minus cosecant of theta. That's what the question said. Could be that you're told it's equal to negative root a over b. What are the values of a and b? All right. Number 6, which is the final example. It's a little more complicated. There's more information that we have to sift through. But the fundamentals are basic, x, y, and r, and those 6 definitions. Secant of theta is 7 over 5. It's a fact that what we can do is say that if r is 7, x is 5, because secant is r over x. Are you all in agreement on that? Could I have said r is 7/5 and x is 1? Sure. Because this r over this x will give me 7/5. Could I have said r is 1? This is tricky. R is 1 and x is 5/7. Yeah. because 1 divided by 5/7 will give you 7/5. But why would you? Why would you do any of that? This arm that corresponds to theta extends forever, forever. It's going to intersect a lot of points. I think you understand that whatever the question is asking, we need to know why. I would hope that you can find y without writing anything down, but 7 squared equals 5 squared plus y squared. Help me out here. Is y squared 24? 7 squared minus 5 squared. Okay, that means that y is root 24. Or is it? It's not. Hunter, why not? And this is a little subtle. Oh, okay. Okay, we'll get to that. We can write it as it's going to be 2 root 6. But even if we did, this is not right. Joseph?
Y has to be negative because cotangent is negative. One of the values of y.
Excellent. We've got to do a little bit of sleuthing here. That, you know, cotangent is negative, but cotangent is is x over y. Well, how can x over y be negative? We already know that x is positive because secant is positive. If secant's positive, cosine's positive. If cosine's positive, x is positive. So that means that y has to be negative. And then we are going to do what Hunter said, which is to simplify the root 24. So what is cosecant of theta? Well, isn't cosecant r over y? Just like really think that through. Cosecant is the reciprocal of sine. Sine is y over r. So the reciprocal of that is r over y. The answer to the question is cosecant of theta is r over is r, which is 7, over negative root 24 24 is 4 times 6, root 4 is 2. So it's 7 over negative 2 root 6. I'm going to throw the negative on top where I always like it to be. If you do want to rationalize this, I'm just looking at the clock and it'll take a minute. If you do want to rationalize this, you would multiply top and bottom by root 6. I don't really know why you would want to do this. Maybe the multiple choices have all been rationalized. Maybe. So I get negative 7 root 6 on the numerator, and in the denominator I get 2 times 6. Root 6 times root 6 is 6. 2 times 6 is 12. See, at this level, what we want to know is can you do all the x, y, r stuff and you work with your definitions? We're not really interested in can you rationalize. So it's a rare event where you need to do it. Really the bottom line here, everybody, with all of these questions you are going to be working on, is this. You know, and you can use your unit circle if you need to. If you are using the unit circle, r is 1, but this is what it boils down to. Tomorrow, what we will be looking at tomorrow and on Thursday is how to find the angles if we know the trig ratios, which is working backwards. Anyway, you can see what your assignment is. Get to work on those, please. I'll come around and I'll give you a hand.